When I look at NASA and the entire effort of flying in space for astronauts and the builders of the space station, I'm overwhelmed each time by the unbelievable amount of effort it takes from people around the planet to make our space station what it is. Every time I've flown, I get an increased appreciation for how many people are involved with this whole effort. Especially now, as a commander, you see what it takes on the ground and around the country and actually around the world now.
With the launch of STS-123 and an international crew of 7 astronauts, the Space Shuttle's mission to the International Space Station will truly be a global endeavor. The flight of Endeavour marks the 25th shuttle mission to the space station and will be the first time that components from all of the international space agencies will be on board the complex. Endeavour's commander is Dom Gorey, a native of Lake Charles, Louisiana, who is making his 4th flight aboard the shuttle. His last mission was as commander of STS-108 in 2001. Air Force Colonel Greg Johnson will make his first voyage into space as the pilot of Endeavour. Johnson, who has advanced degrees from Columbia and the University of Texas, will operate the shuttle robotic arm and assist during rendezvous and docking once the shuttle reaches the space station. Mission specialist Rick Linehan hails from Lowell, Massachusetts, and enjoys outdoor activities and natural history. Linehan, who has flown in space 3 times, is a veterinarian who has logged over 43 days on orbit, including his last flight, a mission to service the Hubble Space Telescope. An experienced spacewalker, Linehan will venture outside the shuttle for 3 of the mission's 5 planned spacewalks. Air Force Major Bob Bankin is a Missouri native who is making his first flight into space. Bankin, who has a Ph.D. in mechanical engineering from the California Institute of Technology, will operate both the space station and space shuttle robotic arms and make 3 spacewalks during the mission. While growing up in the small town of Wadsworth, Ohio, mission specialist Mike Foreman always knew he wanted to be an astronaut. This will be his first mission, and he too will conduct 3 spacewalks. The crew of Endeavour includes Japanese astronaut Takao Doi, who has flown in space once before as a mission specialist aboard shuttle mission STS-87. During that mission, he became the first Japanese astronaut to conduct a spacewalk. One of the major objectives of the mission will be the exchange of Expedition 16 crew members. Flight engineer Garrett Reisman, who received his doctorate in mechanical engineering while attending Caltech, will make his first flight into space and will remain aboard the station when Endeavour departs. Endeavour will bring home European Space Agency astronaut Leopold Eyharts, who has been a resident on the station since STS-122 delivered the Columbus laboratory module. The mission of STS-123 will be one of the longest scheduled shuttle flights in history. It will span 16 days and include 5 spacewalks and complex robotics work. The highlight of the mission will be the delivery of the first piece of the Japan Aerospace Exploration Agency laboratory named Kibo, the Japanese word for hope. That first section is a 14-foot diameter pressurized compartment that will hold experiments, avionics, and other gear. Called the Japanese Experiment Logistics Module Pressurized Section, it is one of 3 major parts of the Japanese laboratory complex that will be delivered and installed on the station during the next several missions. Endeavour and her crew will also deliver a key Canadian Space Agency contribution to the station, the most intricate robotics to be launched into space so far, a multi-armed robot called Dexter.
On this flight, I can't imagine a more exciting series of events. I haven't flown with this kind of mission before, with this many spacewalks and this many robotics operations. It's really an exciting flight to be a part of.
The robotic operations will begin on flight day 2 as Gorey, Johnson, and Doi use the orbiter boom sensor system to survey the shuttle's exterior surfaces to ensure that there is no damage to the heat shielding tiles. The Japanese logistics module, the first section of Kibo, will be moved from Endeavour to the station on day 4 of the flight. It will be attached to a temporary location at the top of the station's Harmony module, awaiting delivery of the main Kibo lab, also called the Japanese pressurized module, on STS-124. After a series of safety checks, Doi will enter the logistics module, Japan's first space station facility. After the work with the logistics module is done during the first spacewalk, Rick Linehan and Garrett Reisman will begin assembling Dexter, a task that will span several days and multiple spacewalks. Dexter is an essential tool for maintaining and servicing the space station. With its dual-arm design and twin video cameras, Dexter will be used to remove and replace smaller components on the station's exterior where precise handling is required.
Dexter is very anthropomorphic. It's got a body, it's got 2 arms, 2 hands. It could pivot at the waist, and it's got 2 cameras, which are almost kind of like 2 eyes. So you can think of it as almost like a human being.
The mission's 4th spacewalk will be dedicated to testing a shuttle heat shield repair technique. The astronauts will test a caulk gun-like device that can be used to apply a repair material into a damaged section of tile to make it safe for a return to Earth. Testing the technique in space is critical to ensure that it is available if needed on future space shuttle missions. On the final spacewalk, Bankin and Foreman will relocate the orbiter boom sensor system they used to inspect the shuttle's heat shield. The boom will be stowed on the outside of the station and not brought back to Earth by Endeavour. The Kibo laboratory, to be launched aboard the shuttle Discovery on the next mission, is so large that the boom cannot fit in its usual cradle along the edge of Discovery's payload bay. Discovery will retrieve the boom once it arrives at the station, use it to inspect its heat shield, and return the boom to Earth. This mission marks the culmination of years of work by people around the world to design, construct, and launch the Kibo logistics module and the Dexter robotic system.
One of the really interesting things about this module is that when it actually arrives, it will be, mark the first time that we're really going to be operating both in Japan and in Germany for ESA and in Russia, and also with the Canadian hardware. So this will be the first time that we really have the entire international conglomerate come together and actually operate the space station together.
I started working with the Japanese Space Agency more than 20 years ago. At that time, the Japanese station module project started. So it has taken so many people and so much hard work to come to this point, and I'm very happy being a part of this project from the beginning. It is almost the realization of the dream I have had since I became an astronaut.
Leading the STS-123 crew on this 25th mission to the International Space Station is retired Navy Captain Dom Gorey. Gorey was born in Lake Charles, Louisiana, but his family eventually settled in Miami.
I had some great teachers, especially in math and science, that encouraged me to really open my eyes to different opportunities and things in our planet and in our world that needed to be looked into, and so I really owe a lot to them.
Gorey took their advice and headed to the U.S. Naval Academy, where he received a bachelor's degree in ocean engineering. His flying career began aboard aircraft carriers before becoming a Navy test pilot while completing a master's degree at the University of Tennessee. After combat duty during Operation Desert Storm, Gorey served at the U.S. Space Command in Colorado Springs before being selected as a NASA astronaut.
It was an unbelievable dream come true, and never really thought that it would happen, but it was a pretty exciting time.
Gorey was the pilot on shuttle flights STS-91 and STS-99 before serving as commander of STS-108, his first trip to the International Space Station. He's excited about a return visit. 2, 1.
And each flight, I think, opens up my eyes even more to the unbelievable amount of effort it takes from people around the planet to make our space station what it is.
Another veteran flyer on this mission is Rick Linehan. Linehan was born in Lowell, Massachusetts, but considers the southern New Hampshire town of Pelham as his hometown.
I can't really say that either of those places, the geographic locations, made me what I am, but I can say that the people I interacted with, my grandparents raised me, and if it wasn't for them, I never would be here. And the teachers that I had growing up through elementary school and into high school, through college, obviously all had a big influence on me in terms of what I wanted to do.
That influence led Linehan to the University of New Hampshire, where he received a bachelor's degree in animal sciences, followed by a doctorate in veterinary medicine from Ohio State. His veterinary career led him first to private practice, then to the U.S. Army Veterinary Corps and an assignment at the U.S. Navy's Marine Mammal Program in San Diego, before he got his dream job as an astronaut.
You know, I remember watching when I was 12 when they landed on the moon, watching all that, and I'm like, my God, they're walking on the moon. Or, you know, when the shuttle flew for the first time, I was in veterinary school, I'm a veterinarian, and I watched all the landings on TV. I used to skip classes to go watch the landings, and I started looking, and they had doctors, and they had geologists and physicists, and I'm like, well, you know, they need a veterinarian because, you know, why not?
Linehan's first two shuttle flights were Space Lab missions, and his third was the STS-123 Hubble Space Telescope servicing mission. This is his first visit to the International Space Station.
So it's going to be a really incredible experience, I think, to open up a hatch and know that you're in a spaceship that just rendezvoused with another spaceship in orbit. I think it's going to be a little like, hey, you know, stick a fork in me, see if I'm done.
Serving as pilot for his first shuttle mission is U.S. Air Force Colonel Greg Johnson. Johnson was born in the United Kingdom, but claims two different U.S. cities as his hometowns.
The two primary hometowns I think I'll claim would be Traverse City, Michigan, because that's where my parents grew up, and that's kind of been a family recreating ground and also visiting ground and a stable place for family history over my whole lifetime. The place that I ended up in high school is probably my second hometown, and that would be in Fairborn, Ohio, where I went to high school.
Johnson remembers one particular visit to his grandparents' house in the summer of 1969.
I was watching a black and white TV in Cairo, Michigan at my grandparents' house, and I watched Neil Armstrong step on the moon. At that point, it set the bit for me to be an astronaut, and it was kind of like a dream, but it really wasn't reality.
Johnson left the Midwest to pursue that dream. He received a bachelor's degree in aeronautical engineering from the Air Force Academy, followed by a master's degree in flight structures engineering from Columbia University. As an Air Force pilot, he flew combat missions during Operations Desert Storm and Southern Watch, and later, as a test pilot, flew NASA's one-of-a-kind NF-15B research aircraft. He was headed to the Pentagon for his next assignment when he got the call from NASA.
So I feel very lucky. I know there's some guys behind me that that could have gotten picked, and they have the same skill set, but it was my lucky day that I got the chance to be selected to be in the class of '98.
Another member of that same class of astronauts is U.S. Navy Captain Mike Foreman. This Wadsworth, Ohio native set his sights on spaceflight at an early age.
And so started exploring, reading about the early astronauts, and found out that a lot of them were in the Navy, had been in the Navy, and my father had also been in the Navy. So I thought, well, the goal to be an astronaut is to become a Navy pilot and then become an astronaut.
And that's exactly what he did. Foreman received a bachelor's degree in aerospace engineering from the U.S. Naval Academy, and after completing an international tour of duty, received a master's degree in aerospace engineering from the U.S. Naval Postgraduate School. Next came test pilot school, while simultaneously applying to be an astronaut.
And then the 8th time I applied, they interviewed me and selected me. So it was a long process. You know, I wanted to be an astronaut since I was 8, and I was 41 when I got here, so it was a 33-year process.
Foreman is joined by another first-time flyer, U.S. Air Force Major Bob Bankin. Born in Creve Coeur, Missouri, Bankin considers St. Anne, Missouri, his hometown.
People were more blue-collar. My dad's a construction worker, teaches at a training school now for construction workers, and I think that what he instilled in me and what the neighbors that I grew up with in my hometown instilled in me was kind of more of a work ethic, and hard work is not something to be avoided.
That hard work ethic paid off when, as an ROTC student at Washington University in St. Louis, Bankin simultaneously studied for and received bachelor's degrees in physics and mechanical engineering. Next came a master's and a PhD in mechanical engineering from Caltech. He then worked developing munition systems for the Air Force before attending test pilot school.
In my test pilot school class, there were probably a half dozen or a dozen folks who were filling out applications while we were students at test pilot school, and that was another kind of a alarm that went off that said, hey, everyone else is doing it, well, you should do it now too, because it might be a good time for you to get selected if everyone else thinks they have a chance now.
Bankin was selected as an astronaut in 2000. He's joined by fellow Caltech classmate and now crewmate Garrett Reisman. Reisman is a Morristown, New Jersey native who grew up in nearby Parsippany.
It's located in northern New Jersey, kind of a typical suburb, if you will, but it really has a really fine set of schools, and that's probably what I point to most as far as what I got out of growing up in Parsippany. I had some great teachers along the way.
Reisman was interested in math and science, but he was fascinated by the images flashed on a screen by his dad's old Super 8 movie projector.
We had a reel of footage from Apollo, and I watched that over and over. Eventually I had, there was the weight of the Scotch tape I had in there to splice it back together when it broke was greater than the weight of the celluloid of the film itself. So, I watched that thing so many times I wore it out.
But he didn't think of astronaut as a career that was actually possible. After high school, Reisman headed to the University of Pennsylvania and received dual bachelor's degrees, one in economics, the other in mechanical engineering and applied mechanics. Then he moved west to Caltech, where he earned both a master's and a PhD in mechanical engineering, before joining TRW's Space and Technology Division, designing the thruster-based attitude control system for NASA's Aqua spacecraft. An outdoor athlete, a scuba diver, pilot and flight instructor, Reisman was chosen for the astronaut corps in 1998. This is his first shuttle mission and first assignment aboard the International Space Station. Serving as an international representative on this flight is Japanese astronaut Takao Doi. Doi credits an early childhood interest as a stargazer for sparking his interest to become a space explorer.
And while I was watching stars, I dreamed about traveling in space, visiting the center of our galaxy, exploring a globular cluster, observing a bath of stars. So I was just fascinated by mysteries of space and what I could learn from space.
Doi was born in the Minamitama district of Tokyo and attended college at the University of Tokyo, where he earned a bachelor's and master's degree in engineering, followed by a doctorate in aerospace engineering. He joined the Japanese manned space program in 1985 and supported the STS-123 Japanese Space Lab mission and the STS-123 International Microgravity Laboratory 2 mission. In 1995, Doi reported to the Johnson Space Center for astronaut training and was assigned as a mission specialist on STS-87. During that flight, he made spaceflight history as the first Japanese astronaut to ever perform a spacewalk. Now, more than a decade later, Doi returns to space to deliver Japan's first piece of hardware to the International Space Station.
It has taken so many people and so much hard work to come to this point. And I'm very happy being a part of this project from the beginning. It is almost the realization of the dream I have had since I became an astronaut.
next for the mission status briefing on ISDN.
I think it was sporty. It was like it was a long flight.
Yeah, Mike. Sure. Nice to see you again, sir.
Good to see you. All right. Hey, this is good. Good stuff. Right.
Good morning. Thanks, y'all, for coming out and welcoming us to Kennedy Space Center. This crew, STS-123, is really excited to be here. Endeavour sounds like it's in great shape. We know we're pushing KSC a little bit, having these back-to-back missions. But once you got a good thing going, you got to keep it going. And I think after this last landing, everybody here is ready to launch another one as quick as we can do it. And this crew's happy to do that. Our next person that's going to walk up is Garrett Reisman. He's our expedition crew member that we're bringing up to the space station, our most important payload. And here's Garrett. Thank you.
I'm very happy to be here. And it's been a long time. Some of us were all in the same astronaut class in 1998. And so we've been waiting for a while, and our colleagues over in JAXA and up at CSA have been waiting to get their elements up on orbit. We're very excited that feeling that we're here today. It feels like this is really going to happen, and it's a great, great feeling. So I'm just happy to be part of it. I'd like to introduce another member of our crew and my Caltech classmate, Bob Benkin, our mission specialist #1.
Just like Garrett said, we're all really excited about the payloads that we're bringing up, and especially the SPDM, the Canadians' new addition to the space station, and we're excited about that as well. I'd like to introduce our illustrious pilot, also an Air Force colleague of mine, Greg Johnson.
Wow. I am really excited to be here, just like my crewmates. I think we probably took the longest route to Florida in the 9.5 years that I've been here. The weather was less than perfect, but Dom led the way. We all came as individual airplanes in a row, but we eventually got here. I see a big group of our trainers over there. Thank you all for getting us ready for this flight. It's going to be wonderful. It's in less than 3 weeks. I would like to introduce the Yoda of spacewalkers, Rick Linehan.
Hello, everyone. I don't know if I'm the Yoda of spacewalkers. I think the Yoda of spacewalkers is standing over there. But it is good to be here. And as everyone just alluded to, this is going to be a very ambitious mission with the SPDM, the Japanese module. And this is probably the most ambitious mission of the 4 I've been on. But the best part of this whole mission, without a doubt, is the crew I'm flying with. They're the best group of guys I've ever flown with, and it's been my opportunity to train with them for the last 1.5 years. And I'm really looking forward to a great mission and coming back and seeing everyone here. And I'd like to introduce, I actually would like to introduce the premier member of our crew. No, it's you, Takao.
You're the man.
I'm very happy to be here finally, and we have been training very hard last year, and I'm really looking forward to this great mission. We have the great crew members and great commander, Dom. 皆さん、こんにちは。土井隆夫です。希望の第一便の打ち上げまでもうすぐです。今まで私たち、激しい訓練をしてきて、ついに、ここまでやってきました。非常に嬉しく思います。皆さんからの応援を非常に感謝しております。頑張ります。皆さんどうもありがとう。Now I'm going to introduce our great mission specialist number 2, Mike Foreman.
Well, thank you, Takao, and thanks for everyone for being here today. People have been asking me the last few weeks if I'm excited about this space flight coming up so soon, flying in here today, breaking out of the clouds and seeing Endeavour over there on the pad. I'd like to say now I'm officially excited. And like a couple of these other guys, it's been a long time coming, but we're ready to do it, so let's go. Thank you.
One of those shots of the cloud would be good.
All right. Thank you so much.
Thank you.
Thank you. Let's go to work. All right.
All right.
Thank you.
Good morning. Thank you for joining us for the Space Shuttle Endeavour's STS-123 Terminal Countdown Demonstration Test Pad Q&A here at NASA's Kennedy Space Center. It's my pleasure to introduce the STS-123 Commander, Dom Gorey.
Thank you, Kendra. Good morning. Thank you for coming out this morning and welcoming us to Kennedy Space Center. We came in yesterday, started some training for a couple days, and we're really excited to be here during this dry count practice run for launch here in a couple of weeks. The Kennedy Space Center is running at a pretty fast pace, as you can imagine, with 2 launches like this back to back. They got a great thing going. We're going to keep it going with Endeavour's launch here on March 11th. We're hearing that Endeavour's in great shape and is ready for us to go. I'd like to introduce Garrett Reisman, who's our expedition crew member we're bringing up, and we're going to drop him off on space station. Garrett.
Thank you. It's fantastic to be here, standing right next to Endeavour, and to feel this close to launch, something that we've been waiting for a long time. Those of us, several of us on the crew, were members of the astronaut class of 1998, and we've been working at this almost as long as our colleagues over in Japan and up in Canada have been working on their elements, which we're bringing up to the International Space Station. So it's a big moment coming up in just a short time, and it's fantastic. It's a great opportunity for me to fly in space on the space station, but the best part is being part of this crew. I couldn't think of a better way to get to where I'm going. So I'd like to turn it over to one of my classmates from 1998 and our pilot and lead robotics specialist for the space station robotics system, Greg Johnson.
Good morning. Thank you all for being here. I'm hoping that in a couple weeks the weather's going to be a little bit clearer for us. We're going to launch on time, March 11th, and I'm totally excited to be heading on out. And here's MS-1 Bob Binkin.
Thanks, Greg. I'm not sure if you were imitating Joe Namath or exactly what you were doing right there, but I'm excited to be down here, be this close to Endeavour, and to be getting ready for a great mission. Folks, Garrett already mentioned the couple of elements that we're going to be bringing up, and we're specifically excited, I guess, about the SPDM and the new Canadian addition to the robotic system on board the space station. I guess with that, I'd like to hand it over to Mike Foreman, our mission specialist, too.
Thanks, Bob. Well, like everyone before me has said, we're excited to be here. It's been a great year or so training with one of the best crews I've ever seen put together. It's been a lot of fun. Very excited to get going on this mission, and want to thank the thousands of people in the Space Shuttle program for making this all happen for us and for all the hard work. And now I'll turn it over to the world-famous Japanese astronaut Takao Doi.
Thank you, Mike. Good morning. I'm very excited to be here today. My main task is to install the Japanese logistic module to the space station. I'm really looking forward to this mission. 皆さんおはようございます。土井隆夫です。もうすぐ希望第一便の打ち上げが、来ます。それを思うと今からワクワクしています。皆さんからの応援、本当にありがとうございます。頑張ります。どうもありがとう。Then I'd like to introduce a great EVA specialist, Rick Linehan.
Thanks, everyone. Good morning. First, I'd like to reiterate the best part of this whole mission, in addition to what you just heard, is being able to fly with all these guys, and especially this guy right here. Kibo means hope, as Takao tells me in Japanese, and I think this mission, the cross-section of people we have, and the cross-section of international projects and payloads kind of sums up what the whole space station program's been about. International cooperation, getting the job done on a multinational level, and I'm proud just to be part of it and get to do and work with people that I have been across the program, and again, especially with this crew. So thanks for being here this morning. Bye.
I'll ask one. Leave it to Dom. I'm not sure who's going to hello, guys. It's Bill Harwood with CBS News. And Dom, I'll ask you, you mentioned it in your opening comments about putting a string of flights together. It seems like this is the first time since, I guess, 2003, you really have had the chance to bang some out of here. And I was just wondering what your confidence level is that the shuttle team has turned the corner on the tank, that you guys are really almost back to where you were in the pacing sense of this anyway. Thanks.
Yeah, Bill, we're really confident in the condition of the tank and the condition of Endeavour. Right now we're not hearing of any critical issues that we're tracking, which is a bit unusual. There's a couple minor things that are getting fixed, like a couple tiles, and I think the radiator retract hoses are fixed, but the eco sensors, the eco sensors from the performance we saw in the last launch sure seems like it's fixed, and we're hopeful that it is. But if it's not, we've got a great plan to look at it and scrub if we need to. But I don't see that being a problem. I think Endeavour's in great shape, and when you got a team that's motivated and up to speed, boy, you want to keep them in the game, and I think that's what we're doing here with a couple successive launches.
Todd Halverson of Florida Today for whoever the Goo Gun guys are. I was wondering if you guys have had the opportunity to simulate your work with the tiles in the thermal vacuum chamber, and I was also curious as to what your confidence level is on flying back home with a repair if in fact you had to.
Well, that's a good question, Todd. We have had the opportunity to train with the STA-54 and in a couple of different environments. We've been in the thermal vac chamber with it, so we've seen a little bit how it behaves in a vacuum. Of course, we haven't seen how it behaves in a vacuum and zero gravity at the same time, so we're looking forward to seeing how that goes. We're confident, though, that we'll be able to get the goo, as you call it, into the tile samples correctly and stow those samples back in the payload bay, bring them home for testing. And I think if we actually had to do the repair on orbit, we'd be confident that the system would work well for us.
Good morning, guys. My name is Suzuki from Fuji Television, Japanese TV. I'd like to ask Mr. Doi, yes. Excuse me to speak English. No, Japanese. All right. 土井さん、おはようございます。2つ質問があります。 1つ目は、97年に続いて、2回目のシャトル登場になるわけなんですが、お気持ちのもし違いみたいなものがありましたら1つお伺いしたいと思います。でもう1つは、今回は日本初の有人宇宙施設、第1便ということになりますが、改めてそれに関する意気込みを、お伝えいただきたいと思います。
Can I speak in Japanese? That's one quick translation. はい。前の私のミッションから約10年、経ちました。そういうそのためもあるし、また今回私の仕事っていうのは、前回と違ってロボットアームをするとか、ランデブーをするとか新しい仕事が入ってます。そういう意味で、新人のような気持ちで今まで訓練してきましたし、この素晴らしいクルーと一緒に頑張ってこれだと思います。今ここでローンチを目指して、最後のトレーニングしているわけですけれども、非常にワクワクしていますし、嬉しく思っています。
あと第1便、
はい、そうですね。それで2番目の質問ですけれども、第1便、希望の第1便を、宇宙ステーションに設置するということは非常に、光栄であると思っています。私自身が、JAXA に入った時、それは今から約20年前になりますけれども、その時にちょうどこの、スペースステーションプログラムが日本で始まったんですね。でそういう意味で、私も、私が一緒にスペースステーションと一緒に成長してきたということで、このミッションできるということで非常に、嬉しく思っています。The first question is how I feel about this mission. Since I flew in 1997, STS-87, so my answer is I feel kind of freshman because I'm doing new jobs like rendezvous and attaching the logistics module to the space station with the shuttle robotic arm. And the second question is how do I feel about attaching the Japanese first module to the space station about this mission. And I'm very honored to be able to participate in this mission, and I'm very excited about flying with a great crew. Thank you.
Thank you very much, guys. Good luck.
Good morning, Keith Scala, Space Age Times. Just wondering for the EVA crew, is there any special task that you trained for that you trained for a little longer, or any particular EVA or EVA task that concerns you with this mission?
Well, the training flow has been an intense one, EVA-wise, all around, and we have two major objectives here. First one is to get the SPDM or Dexter built on the first series of 2, maybe 3 EVAs, and then Bob and Mike will be going out and doing some important stuff with OBSS booms and some other, as you just heard, the TRAD, DTO, the STA-54. So those are really critical EVAs, and Bob and Mike will be making up the vast bulk of that in the last 2 as they go out. Training-wise, it's been fast and furious. We've concentrated on all the major tasks and had a few things come in, add in as we go, which we maybe not have expected, and we're catching up on those and doing our best to train. I think we're ready. We've got some things we need to look at on Space Station in addition to getting the major task done, which is the SPDM, moving the Japanese, the ELMPS, which is the first up with Garrett and I on our first EVA, to disconnect that and then robotically move that to attach the station. The main objectives have been trained, they're solid, and we are, I think, well versed in pretty much everything that we'll need to do when we go up there on EVA. So we're in good shape.
Thank you.
Good morning. My name is Noriaki Takada. I am a Japanese TV reporter for Nippon TV. おはようございます。土井さん、よろしくお願いします。質問2つございます。先ほどちょっと質問かぶるかもしれないんですけども、今回のミッションにかけてですね、訓練されているところ、特にやっぱ大きく違うところとか、大きくその気持ちの上で、違うところをまた教えてください。それとあと、こんな時期に、ご質問するのもなんかと思うんですけど、オフの日にですね、何をされるかというのを考えがもしありましたらよろしくお願いします。
最初の質問ですけれども、 先ほど、フレッシュマンのような気持ちで、今回のミッションに臨んでいると言いましたけれども、それと同時にですね、やはり、前回の経験があるので、今回訓練をしながらですね、自分で何をやらなくちゃいけないのか、何が足りないのかですね、よく、自分で理解してですね、受け身というよりは、積極的にですね、この訓練が必要だとか、こういう活動をしなければいけないということで、前回と比べてかなり積極的に、自分からですね、進んで訓練ができたと思います。はい、それから2番目の質問ですけど、オフに何をするかということですけれども、やはり、宇宙に行って一番の楽しみはやはり無重力を楽しむということ、それから地球を見たい、もう一つは今回素晴らしいのはやはり宇宙ステーションがあるということで、宇宙ステーションの中、じっくり探索してみたいと思っています。The first question is, what's the difference between this mission and the last mission in terms of preparation, training? And my answer is, although I feel I'm a freshman for this mission, but I had a kind of experience before, so I knew that what I needed to do for robotics training or rendezvous training, and I was kind of being more aggressive to get training which suited to me. The second question is, what am I going to do when I have free time? And of course, I wanted to experience play with microgravity, and I like to observe various parts on the Earth. But the great thing for this mission is we can explore the space station. That's what I wanted to do. Thank you.
David Hirsch with NHK, Japan's public broadcaster. Just to follow up on that answer, if I could ask you, in your exploration of the space station, what particular areas or what particular activities you expect to be doing? And Commander Gori, if I could ask you to pass that microphone after that answer all the way down to talk a little bit about the partnership and the importance of working together with JAXA in this mission, and really for the year ahead for JAXA.
Yes, of course, my first objective is to configure the inside of the Japanese logistic module, so I'll be working there a lot, but I'm also interested in many different modules, Russian module and the US module, and this time Columbus module. So I really would like to explore just all of the station modules. Thank you.
That's all the time we have for questions.
Just for Commander Gori, if we could.
One of the great things about this flight is working with a partner like JAXA in Canada with the two prime payloads we're carrying. You asked about JAXA and the Japanese Space Agency. Anytime you're faced with a new partner, you're not quite sure how they're going to perform, but in this case, we've got a superb, unbelievably competent group of engineers that have given us a piece of hardware that has no issues, and it's beautiful. And what we sense from all our interactions with JAXA is an excitement level that is hard to contain. They are beside themselves with excitement and energy on getting this thing up to orbit, and it's been contagious, and everybody that's works with them has been really excited about that. So we're really looking forward to bringing it up for them and watching Takao go in as the first guy into the module. It's going to be an exciting time for us, and as the next GEM module comes up, I think it's just going to be a great partnership. The space station, the size of it is exploding, a lot larger than the last time I visited, and it's going to be exciting, like Takao said, to go explore that thing and see the size and just the technical advances that we've made in the whole laboratory system up there. So we got a great partner with JAXA. We're looking forward to continuing. Thank you.
That's all the time we have for questions. For a small photo opportunity.
Thank you. Get the photo off.
Pad B, and the simulation just comes to a knockout down the fence. Watch your head. Sorry. Pull out is spring-loaded, turn it straight up and down. No matter which way it's cocked, it could be cocked to the right or the left. When you turn it straight up and down, just reach up and tap the driver on the back and say, let's get out of here. So.
opening tool. Here, there's a belt cutter in here. There's hand lights. And that's pretty much what happens. Renee, I'll go ahead and turn over the chair portion up here and get in there. It gets swinging. You get to hit the path. We load from number 1 on. You all from the right side in. For example, if someone got out of sequence, let's say they took this. 1.
And they recommended that method because it makes it a lot more stable. Also, if you're sitting down, you don't have to worry about those elbows. What do you want? I'll get the D1. Now, you will periodically have this rope foul this, or it can happen. If it does, just push the rope out of the way and it's still going to drop. You know, just like that. Then grab your bar. Then the next person do the same. Then you'd grab the bar, and then the third person out.
It's got 10 minutes worth of breathing area to the M113 and off to the helipad just fine. Good breathing.
Roger. Good work.
No, that'll be fine for Rick.
Yeah.
That was too big on you.
Yeah, a little space in the center. What's that?
Not presentation. It's fun.
You want to touch the hardware? Put this on the black. A little black. A little black pieces all over the How are you doing, Alex? Ready for you? Right here. Ready? Pat, you okay? Yep.
Oh, I got you. Yeah, she's got this leg. They're better. They actually bend a lot. Thumbs up.
pictures.
Like this question
in the background.
Right, but he was looking at the same time.
How you doing? Here in my corner.
Yeah, that's where he belongs.
A little better. This is still tight on that one side.
George, we have a little electric. Ready? Yeah.
Thanks.
I think that'll do it. Just make sure we're doing the right thing there.
Got everybody?
Yeah.
Good work, baby.
All right. It's gorgeous up here. I want to climb inside that box.
This is the nicest DCAT I've ever.
Yeah, Mike. Doug on me said, I got you.
All righty.
Good afternoon and welcome to today's STS-123 Post-Flight Readiness Review News Conference. With us today are NASA's Associate Administrator for Space Operations, Mr. Bill Gerstenmaier, Space Shuttle Program Manager, John Shannon, and Shuttle Launch Director, Mike Leinbach. We'll begin with some remarks here and then take questions from Kennedy and other NASA centers. Mr. Gerstenmaier.
Thanks, Mike. We had a very thorough review over the past day and a half. The teams are ready to go launch here on March 11th, and we set the launch date as March 11th. We're really not working very many open items, and that's a tribute to the team and the great performance of Atlantis. There wasn't a lot of work that we're carrying forward out of this review into the next review at L-2, so that's a tribute to the team, and it's also evidence that we're really ready to go fly and we're not rushing things or things are not being moved too fast. As we look at this mission, you know, I tell you almost every time that this is an extremely complex mission. This mission is just as complex as the other ones. It's a full 16-day mission with the power transfer from station to shuttle. There'll be 5 EVAs on this flight. The orbiter boom survey system will actually stay on space station after flight day 12. So they'll do an inspection while we're docked and then stow the boom on space station. That's so there's enough room to fit the Kibo pressurized module on the next flight into the cargo bay. And then that's a little unique for us, but we talked about that in the review. Also, the ATV launch is scheduled for the 8th. So the ATV will be in orbit when the shuttle launches. So we need to look at our TDRS communications. We have some single access antennas that provide KU band data to the shuttle and station and also to ATV. We need to share those between the 3 vehicles, so there'll be some times during the mission where we may not have comm with the orbiter like we normally do. We'll have comm periodically during an orbit, not all the time. So we discuss that. We make sure we have the right plans in place. If we really need comm with all 3 vehicles, ATV, shuttle, and station, we can do that. We can set it up. From a scheduling standpoint, we'd like to try to minimize those periods where we need high-rate communications with all 3 vehicles. And they presented to us a very intricate plan to all that worked out, and they've looked at all the contingency cases, and that looks very good. From a contingency shuttle rescue standpoint, the space station has 86 days of capability, and the shuttle needs between 69 and 71 days or so to get the shuttle ready, so there's a good overlap there, and that meets our requirements. The other thing that I picked up from the meeting is this is an extremely international flight. We had presenters both from the Japanese Space Agency talk about their module, their activities. We had the Canadian Space Agency talk to us about their robotic, Dexter, the special purpose Dexter's manipulator that will be used to essentially save EVA time, and we got to hear a very good discussion on that. So again, I will tell you that it was a very thorough review. We covered lots of information, lots of data. The teams are truly ready, and it's a tribute to the teams that they worked so well with the vehicles before the processing that we're even able to come talk to you at this point. They've done just a phenomenal job. So with that, I'll turn it over to John.
Okay, thanks, Bill. It is great to be back here at Kennedy Space Center. We landed STS-123, was it 9 days ago now, and which is just amazing to me. And the fact that we could come back here and set a launch date for the next flight that quickly is just a testament to how well the vehicle performed, how well all of the supporting infrastructure and ground equipment performed. I was a little surprised as we were going through the review at how detailed the data was from this last flight. The solid rocket booster team had already torn down boosters and gave us great updates on their status. The orbiter team, the external tank team, they did the same things. The external tank guys looked at all the imagery that we had from the last flight, gave us a very detailed review of how the tank performed, which was very good. On the orbiter side, the only thing that was still left a little bit open, we had looked like a short circuit that took some power from some of the small steering thrusters, and we have not had time to get back into the aft to completely troubleshoot that. So we talked a little bit about what that would mean to us if we had that on this flight, and it would not be an impact. So that work is still progressing. So the team did a great job in going through in detail all of the engineering data that we recovered from the last flight. I would agree with what Bill said. Space is getting to be very busy. We went through the ATV plan and the comm plan. We will have some outages. The operations team has looked at that very closely and understands exactly what data we will have when, and has tailored the mission to accommodate that. That's a very good thing that we're getting more vehicles up to space station to supply it. We went through individually each of the various elements in the program. We started with the integration team, reviewed all the debris status, debris issues. We had no updates to our hazard reports or anything from this last mission. On external tank, when they briefed, it was interesting to me that this is the last of our modified tanks. This was one of the tanks that was ready to go before Columbia, and it's one of them that we took back and we did all of the rework on. The next flight that we fly will be of a tank that is what's called inline processing. All the mods were made as the tank was being built, and we did not have to send it back for rework. Solid rocket booster, we talked about the parachute failure we had on the left booster and what potentially caused it. The team recovered it all, and they looked at it. I think it was a sudden burst where we got asymmetric loading on that chute. And our history on that, we do have some history. It's very low, though. We've had 10 failures out of 720 parachutes in the history of the program. And since we put rip stops in the chute, we've only had 2 failures, and haven't had any since STS-89. So the performance has been pretty good. We actually even showed an Apollo 15 capsule landing that had a chute that did not inflate, and talked about why that happened, which was interesting to me. Orbiter, the orbiter performed unbelievably well. Atlantis performed so well on STS-122. There are a few new things that we went through. We talked about how we're going to do our inspections of the vehicle. We are doing inspections even though we're leaving the boom up on the International Space Station. We're going to use it before we leave it up there to do a MMOD, micrometeoroid orbital debris scan, just like we do when we undock. It'll be a little different configuration because, of course, we're having to work around station structure, but we'll get that accomplished on flight day 12, and then we'll leave the boom up there. We also talked about the TRAD DTO, which is our goo gun. We're going to, on EVA number 4 on this flight, 4 of 5, we're going to put a sample kit on the bottom of the lab, and astronauts are going to go down there and use the real tools they would use and the real equipment to repair a tile. It's just like we had planned to do on STS-120, but we were not able to do that because of some other activities on orbit. So we're looking forward. You know, that's part of our progressive understanding of our repair capabilities and our inspection capabilities. So we're looking forward to that. One thing you might see, and we talked about this a little bit, is we're putting a flash on the orbiter side in the umbilical well that will flash to give us our external tank pictures, the nice pictures we get. A couple flights, I think STS-121 was in the dark, and we didn't have any data on that, and that was okay, but we like to see the performance of the tank. So we added this flash, which is good out to, you get good resolution even 130 feet away. We did some tests on it. So don't be surprised when we get external tank separation and the orbiter, you can just barely see the silhouette going away, and every 2 seconds you see a real bright light. So that's just the flash going off to give us some data. It also should flash at just before solid rocket booster separation, because we take pictures with those same cameras kind of obliquely of the aft part of the booster. So you'll see those. That'll be something new on this flight. Bill covered it. This is 16 days, 5 EVAs, huge international partnerships. The team is turned around and ready to go for this next one, and I couldn't have been more happy with the review today. It went very well. That's all. Mike.
Okay, thanks, John. Well, processing of Endeavour out at Launch Complex 39A is going extremely well. We're right on the timeline. The program challenged us to do a rather quick pad flow this time with essentially no contingency days in that flow, and the team stepped up to that challenge, and I'm pleased to report we're right on that timeline. We will finish our hypergolic loading this evening, open up the launch pad, and get into our closeouts of the aft compartment of the orbiter starting tomorrow morning. Sunday evening we'll get into the final ordnance installation and connections, and next week is a week of pad closeouts. We'll pressurize the high-pressure GN2 and helium tanks on board the orbiter, looking for a call to stations for launch countdown at about 2:30 in the morning on Saturday morning. So right now all things are going really well on Endeavour and the other supporting systems. We have a nice low number of problem reports out there that we're working through. So Endeavour is doing really, really well. Looking forward to launch on the 11th. That's it.
Okay, we'll take questions first here at Kennedy. Please wait for the microphone, state your name and affiliation, and to whom your question is directed. Marcia?
Yes, Marcia Dunn, Associated Press. I'm not quite sure for who. Was there any discussion, or is there any concern, even small, about any debris from the satellite that might pose a little extra risk during the launch or thereafter?
We took a look at that. We had our analysts take a look at the latest predictions of what debris is remaining from that event, and we calculated it, and it really poses no risk to the shuttle with where we are. There's a small change in risk over the mission. We think we went from 1 in 269 to 1 in 259, which is just a minor trivial change. We probably don't know the debris model that well to see that kind of difference. So we looked at it, we reviewed it, we continue to talk to folks to make sure there's nothing, but we don't see any concern or any problems.
And I was curious to know how much percentage less TDRS coverage you expect out of the shuttle mission, given all the stuff going on. And I was curious to how long the inspection boom will stay at the station. Does it come back on the follow-on shuttle flight, or does it stay up longer?
In terms of the TDRS percentage of time, we don't have that calculated yet. We still need to take the actual launch vector from the ATV once it launches and understand when they need their coverage. It's also, ATV doesn't need communications all the time, so it's a function of how well their mission is going, so we don't know that. The same thing on the shuttle station side. We don't know exactly when the shuttle's going to launch, or we know when it's planned. So we're still running all those state vectors and looking at that analysis. But what we put together is just a basic framework of how we make the decisions of who gets priority for comm during which periods, how we schedule that with the TDRS network, et cetera. So we don't have a fixed percentage per se. We'll see what we get once we get on orbit and see how things work out. And then John can answer about the boom.
Yes, it will come back on STS-124.
Why don't you just leave it up there? Is there any reason why you just can't dock it there permanently?
No, there's no reason that we couldn't dock it there permanently. It's we're going to fly without one, so we would like to take it off and use it to do our inspections later in the flight. And we also have we only have a couple of three booms, so if we left one up on station, I would have to take a boom and move it from vehicle to vehicle here at Kennedy Space Center, and they are very tailored. It's a very tailored setup in the pedestals that hold them on each vehicle, and that'd be a real pain. So I'd like to bring it back and just match it to a vehicle and use it that way.
Bill?
Bill Harwood with CBS. For Mike, can you just refresh us on what the range availability is and what your strategy is going into this? And I've got to follow.
Yeah, the range availability, there is a Delta mission off the range on March the 15th. And in order to turn around the range from our launch attempts to theirs requires 48 hours. And so we have 2 launch attempts for the shuttle program, the 11th and 12th, and both are obviously a very early morning. If we don't launch by the 12th, we have to stand down for the Delta program. And that's about a 5-day stand down when you add all the factors together. Our next launch attempt would be the 17th. So we have two good attempts, 11th and 12th.
Thanks. And one for John. Given the length of the mission and the power transfer system, is there any plan, back pocket or otherwise, to extend this flight other than system issues? In other words, is there something you'd like to do if you have the time or the power? Or can I assume you really are going to land on the 26th if you launch on the 11th? And one for Bill Gerstenmaier, a real quick one. You said 1 in 259, and I didn't know what that refers to. Thanks.
Let's see, mine was, would we extend our recent history would say that we would always consider it for anything that goes, and right now we have 16 days. We have 1 extension day that we could add to the flight. Right now, the entire mission fits inside those 16 days, but it is very complicated. It's a very complex mission. We're doing a lot of different things. So I wouldn't say absolutely we won't extend or not. We have that option available to us, and we'll look at it as we always do. Matter of fact, during the FRR, we talked about would we take a launch window that gave you a flight day 4 rendezvous opportunity, and we would do that. We would take that extra day to do that, just to get off the pad. So it's always an option.
And again, I'd add to that a little bit that it's with ATV launch on the 8th, and then when their docking day occurs prior to the Soyuz, that factors into all this logic. So by us extending the day, that may keep the shuttle in orbit such that it puts some pressure on when that docking day is available for ATV. So there's a new piece of data there we now need to factor in. It's not only just the shuttle mission duration we need to think about, but now we need to think about the ATV mission and where the ATV dock occurs. So life is getting more complicated, as John said at the beginning. We've got lots of stuff flying in space. And those are risks that I gave you in terms of critical penetration of the orbiter for micrometeoroid debris. It's 1 in 259 and 1 in 269 risk of
well, I just
critical
need
penetration.
You mean over the course of an entire mission, there's that odds of it? Okay.
Over the course of the entire mission, yes.
Irene?
Thank you. Irene Klotz with Reuters. I have 2 ATV questions and one on GEM, so these are probably for Bill. Where will the ATV be located during the STS-123 flight if it launches as planned on the 8th?
Yeah, it's going to be in essentially a parking orbit well away from station. I don't remember how far it is. I think it's 1,000 kilometers, maybe. I don't remember. Do you remember, John?
I'd get it wrong.
I don't know, but it's an extensive distance away from station and shuttle that it's not a concern to us. What they'll launch, they'll do a collision avoidance maneuver after they first get on orbit to verify that capability works with ATV. Then they'll do an attitude control system checkout, and then they essentially loiter at this large standoff distance from station and shuttle until the shuttle is undocked, and then they'll come in after that. Then they'll do 2 docking demo days. They'll do a docking demo day 1, and maybe as early as the 29th, and then they'll do another docking demo day around the 31st of March, and then that sets them up for their actual docking then a day later. So that's the general plan.
Thanks. And also with ATV, if there were a delay or a launch accident, would that affect the shuttle launch at all?
No, they're independent from that perspective.
Thank you. And then also concerning the Japanese module, will the station crew have use or access for the section that's being launched on 123, or is that really not come into play until the main pressurized lab flies in May?
They will ingress the module. It doesn't have full-up fire detection and some of the other capabilities, so they'll limit the amount of time they're in the module, but they will go into the module, activate some of the racks, and see some of the things. It's in a temporary location, as you know, on top of the node, then it eventually gets moved on top of the Kibo module later when the Kibo module comes up. You know, it's providing basic, and you'll see it in the press kits, it's providing basic computer systems for the Kibo module. It provides the rendezvous prox ops equipment that will be used when the HTV flies in July of 2009. There's actually 8 large racks inside this Japanese pressurized logistics module that all play a key role in the Kibo module itself when it comes up. And it turns out that the Kibo module is too heavy to fly all these systems racks in place. So it essentially takes, you could think of it, 2 flights. This brings up all the equipment and electronics are stored in here, and then some of those key systems will then move into Kibo when Kibo gets attached on the next shuttle flight. So that's the way it works. The other thing that will be exciting is that this will bring up the Japanese Control Center. So we will now have not only the Columbus Control Center in operation, we'll have the ATV Control Center active in Toulouse, and we'll have the Japanese Control Center active in Tsukuba. So talk about an international event. This is huge in terms of all these new control centers coming online, all working together internationally and being coordinated and sharing information back and forth about how our mission affects their mission, how their activities affect ours. It'll be a lot of work for our friends in the Mission Operations Directorate to coordinate all this activity. But it's what we've been training for, it's what we're getting ready for, and this is really the international portion of the International Space Station.
Okay, we'll take one more here before we go to questions from Johnson Headquarters and the Jet Propulsion Laboratory. Patrick?
Patrick Peterson with Florida Today. Have the damaged components from the Sarge been examined yet, and have they told you anything about what the repairs might require and when you might do them? And is there a deadline, and what is the deadline for making those repairs?
I know the components are on the ground and they've been shipped, I believe, to Marshall to begin the failure investigation. I don't know how far along they are in the failure investigation, but they're there. In terms of what we're doing with the solar array rotary alpha joint is we've been analyzing each mission to see if we have sufficient power for that mission and then the following stage after that mission. We reviewed that in detail at this flight readiness review. There's no concern at all with this flight. We have plenty of power for this entire mission. through all the EVA activities, through all the docked phases, and then after undock, we also have sufficient power to go all the way to the stage to the next period. The teams have preliminarily looked at the next flight, which is the Kibo flight, the 1J flight in May. Again, the power looks fine there. The period after that looks fine. They're in the process of working through the ULF-2 flight in the fall. They're looking to see if there's sufficient power there. It looks like there will be. And then the stage after that, power in that stage. So we're essentially, like I said, I think last time at the landing review, we probably have sufficient power with this array, even in this degraded position, to stay until probably the end of the year. We still need to do a little bit more work to confirm that, but then that says we've got a little bit of time to analyze the components down, get a good troubleshooting plan in place, and then go implement it at the right time. The other thing I will add is on one of the EVAs, I don't recall which one, they're going to reinstall the trundle bearing assembly, you know, the one that we returned from space station for analysis. We're going to put that back in the solar array alpha joint. The purpose for that is that that gives us essentially the ability to rotate that joint a little bit more if we need to for gaining power and other activities. So it gets us back in a more normal configuration. But I think that's the only activity that's planned for that joint on this mission.
Okay. Go ahead, Patrick.
Did you say you're going to reinstall the same bearing or a new bearing?
New one.
New bearing.
A new bearing will get reinstalled.
All right. We have a reporter standing by at the Johnson Space Center in Houston with a question. Go ahead, JSC.
It's Mark Carreau from the Houston Chronicle. I had two questions. The first one follows on Patrick's question about the trundle bearing assembly that you're going to put in. I just wanted to make sure I sort of understood where this takes you. In the interim, does this then give you some ability to rotate the joint in the beta direction if you want to in the coming months before you effect a total repair?
Yeah, Mark, we replaced the beta gimbal before on the last flight or during the stage, excuse me. So we have full capability to track the sun in beta, and that's the angle of the sun with respect to the orbital plane. So these arrays are actively tracking in the beta direction, so that's fine. They're doing as good as they can, but they're not tracking like sunrise to sunset or the angle of the sun, you know, as the sun rises and sets in that particular day. That's the alpha joint. We have the ability to rotate it now. We're going to move it prior to docking, we'll move it during undocking, and we'll move it during one of the EVAs during the flight. So we can move it when we need to by putting this new trundle bearing assembly back in. If we needed to rotate it a little bit more, the teams are more comfortable with it having it in a known configuration with all the trundle bearings in place to let us rotate it a little bit more if we need to position it. So our plan is to periodically position it to optimize for power generation. Then we'll stay in that configuration for a couple months. Then we'll go ahead and move it to another position to go ahead and move it. So we can move the alpha joint when we need to move it, but we don't want to auto track with it. We don't want to automatically track the sun, and we want to limit the motion of that as much as we can. And that's the basic ground rules that we're operating under. Mark.
Thanks very much. And I think this is for John Shannon. It goes back to your opening remarks about the flashing for the camera work. And I wasn't quite clear where the light source is for the photography that you plan. And does this help you get pictures in darkness, or does this launch put you in a lighted condition regardless of that? I was just trying to see if there was a connection there, and if you don't mind taking a moment to sort of explain what the light source is, if it's some kind of diode or what it might be.
Okay. We are launching in the dark. The tank will be dark at external tank separation. The flash is located, it's actually two almost standard off-the-shelf Nikon flash units that are in a special housing that has the power source as well. They're located inside the umbilical well, which is where the big feed lines are going in. That's also where the cameras are that take the pictures of the external tank. And those two are synced up. So at separation, you'll see where it's the back area where those two little doors are. You'll see that flash coming out of the port side one, and it'll flash. It'll take 8 seconds after separation. It'll flash every 2 seconds, and I think we get 23 flashes as we go through all of the pictures that we take.
Okay, next we have questions from NASA headquarters.
Tracy Watson, USA Today. Do you get the full 16-day mission without any conservation measures, or would they have to conserve some power to get that far? And what about adding an extra day? And then I have one more. Thanks.
Yeah, Tracy, with the Spitz capability that we showed 2 flights ago, we will have 16 days without any additional energy conservation measures by the astronauts. We'll go into our normal on-orbit power down, but the Spitz provides all of the extra power that we need.
Okay, thanks. And another one for John Shannon. One of the presidential candidates said recently that he thought that space shuttle flights don't stimulate the public imagination like they once did. And I'm wondering if you could address that and maybe talk about this one in particular and why maybe he's wrong about that.
Well, you know, I find that hard to believe, and if that is true, that's a failure, I think, on my part and other folks at NASA that try to explain what we're doing. If you would have sat in the meeting that I just sat in to go through what we're doing on orbit, it is truly amazing. And the amazing part to me is not just the technical piece of how difficult it is to get all of this hardware up on orbit and assembled and provide the laboratory that we're providing, but it's the international cooperation piece. And the fact that we're going to have a control center in Russia, in Germany, in Japan, and in the United States is a phenomenal undertaking, and the team has really pulled it off well. And some folks have talked about my new job here and what Wayne Hale, the previous program manager, is doing. And I think it may be an effort to address things like that. Is that we're not getting out the word well enough about how difficult this is and what it provides back to the country and to our standing in the world and with international cooperation. So we're going to keep trying to get the word out because it really is amazing things that we're doing up in space.
And I'll add, Tracy, that when the JAXA representative presented the plan for the Kibo logistics module, he gave an extremely professional technical presentation on how his module was ready to fly, how they'd prepared it. And then at the end, I kind of just off the cuff asked him if he was excited about getting ready to go fly. And for a moment, he broke from the engineering cold stone face look and almost jumped up and down and said, we are really excited to go fly and see our hardware get to orbit. So when you talk about the excitement of what we're doing, it was really captured in his exuberance. They've spent many years preparing their hardware, both the Canadian robot Dexter and then also the Kibo logistics module. They've dedicated decades of time to get this hardware ready to go fly. And then to have the Kennedy folks show them pictures of this hardware sitting in the cargo bay out on the launch pad ready to go launch, they are extremely excited and emotional about what's going on. So I will tell you that the folks that understand what we're doing are very excited about this. And I echo what John's saying. We need to do a better job collectively of letting other folks know what we're doing and how neat this business is that we're in. I also got a piece of information that the ATV will stay 2,000 kilometers away from space station. So you can get that.
Okay. All right, now we have a question from the Jet Propulsion Laboratory in California. JPL? Okay, we'll try to go back there. Let's go around the room again here if anyone has any questions. Marcia?
Two quick questions. I know now that you can keep the shuttle up longer because of the Spitz and all that, but what is the length of time that you wouldn't want to go past for pilot fatigue, stamina, health for safely landing a shuttle?
You or me? Well, and I'm reaching back in the memory here. This is the longest that we will have for an ISS mission, but we have flown space lab missions. We did it in a build-up period of time, and I believe we got out to an 18-day flight. Bill's nodding, so I know I'm on good footing here. So we would talk about it, and as I told you last flight, we have flight doctors that are constantly talking to the crew and understanding how they're doing. They exercise, which is a great mitigation against any neurovestibular problems during landing. And they also have a training system that they can fly on a little laptop with the real hand controller they'll use to fly. So we put a lot of mitigations in that we learned in our space lab build-up. I would say that we would still be within our flight history even if we extended the mission the additional day, and even if we had a weather wave-off day. So we'll be within our normal period of time. But this is a long mission. It's a long mission, and it's something that we have paid a lot of attention to.
A quick follow-up to that, too, would be, is this the longest for the rest of the program, or is there another one out there that you think might surpass this? And secondly, is March 23rd still the date that you're looking at to want to get off the ground to get back in time to give way to the Soyuz?
Yeah, the answer on the second one is yes, that the window for the 16 Soyuz starts on the 24th, so the 23rd would be the last day. We have, I think 2J additionally is going to be a 5 EVA 16-day mission, so we've got a couple more on the books.
Irene?
Thanks. Irene Klotz with Reuters. For John, is this TRAD demonstration a absolute must-have before the Hubble flight?
No, it's not. It's we feel very confident in the tools and the equipment. We've done them in thermal vacuum chambers with suited astronauts on the ground. All this will answer is a materials question on its behavior in microgravity in a vacuum. Right, we have the vacuum right now, but we don't have the microgravity piece of it. We feel very confident that it will work, but this is kind of the last and final test to show that everything is working okay. So if I didn't do this, I would still feel very comfortable if I needed to use it on Hubble or any other mission. Sure.
On the topic of international cooperation, are there any other communication satellites that possibly could be used for station, probably not shuttle, but station or ATV, or ground to space?
Yeah, we're really geared for the TDRS use, and we did a test on the last flight. Again, we call it virtual spacecraft. That's where we can use one TDRS satellite with its antennas to communicate with both the shuttle and the station. So we've already put an efficiency in place that allows us to give us more flexibility, and we tested that on this last flight to make sure that all works. But there's not another satellite available internationally that we can use for this function.
Patrick?
Patrick Peterson, Florida Today. I wanted to clarify, will this be the longest stay at the space station or just one of the longest?
It's the longest to date ISS mission, yeah.
Any other questions here? We understand there's no media at JPL. So we'll close with a couple of NASA TV programming notes. The STS-123 crew arrives a week from tonight, Friday the 7th of March at 9 p.m. Eastern Time. The countdown picks up on Saturday the 8th at 3 a.m. And our launch coverage begins on NASA TV at 9:30 p.m. Eastern Daylight Time, Monday, March 10th, leading to a launch on the 11th at 2:28 a.m. Also, don't forget, as always, you can track the mission and the crew on our website at www.nasa.gov/shuttle. With that, we'll close. Thank you very much for coming.
evening. Thank you all for coming out and welcoming us here in this wonderful weather we've got. I think while we get the weather done with today, we're going to have a nice shot at launching here this week. But we all just wanted to convey how excited we are to be here for launch week. We've got a great training team that got us ready. We've got multiple shifts of folks at Mission Control waiting to run this 16-day mission with us. And we got a very, very ambitious flight schedule. But with a great orbiter waiting for us and this great crew, we're going to have a great mission. Thank you very much. Yeah, I'll have a nice evening. All right.
From Launch Complex 39 at the Kennedy Space Center in Florida, this is Shuttle Launch Control at T-minus 3 hours and holding, with 1 hour, 1 minute, 48 seconds remaining in this 2½ hour built-in hold. We're in the final 5 hours of the countdown for the launch of Endeavour on mission STS-123. The countdown is being controlled from Firing Room 4 at the Launch Control Center, and we are on schedule for liftoff at 2:28 a.m. Eastern Time, making this the 30th night launch of the shuttle program. This is also the 122nd launch of the Space Shuttle, the 21st for Space Shuttle Endeavour, and the 25th for construction of the International Space Station. The primary objective of the mission is to deliver the Japanese pressurized logistics module to the International Space Station, which will later be attached to the Kibo laboratory to be launched aboard Space Shuttle Discovery in May. Also aboard is Dexter, the Canadian Special Purpose Dexterous Manipulator, which we attach to the Canadian robot arm already on and in use at the space station. There are 5 EVAs, or spacewalks, planned for this mission, which is scheduled to last 16 days. This will be the longest planned mission to the International Space Station to date. Landing is currently planned for 8:35 p.m. on March 26th. There are 7 astronauts who will shortly be aboard Endeavour en route to the International Space Station. The astronauts are STS-123 Commander Dom Gorey, STS-123 pilot Greg Johnson, Mission Specialist number 1, Bob Bankin, Mission Specialist number 2, Mike Foreman, Mission Specialist number 3, Takao Doi from NASDA, Mission Specialist number 4, Rick Linehan, and Mission Specialist number 5, Garrett Reisman.
It looks like Dom Gorey's coming up here, and of course he's the commander of the mission, his 4th flight, and this is you could call it almost routine for Dom going through this. This is a significant milestone in the process, of course, especially for the first-time flyers, actually getting in the suits for the final time. Here we have Greg Johnson, the pilot, and they know they're going to get in these suits, and they'll do pressure checks, take the helmets and gloves back off, but then stay in the suits till they take the trip out to the launch pad and strap in, and they don't take them off now until they're in orbit. Now Garrett Reisman here is this is his first flight, and hey, that's a cue that I gave him, the wave. Not really, but he's going to go and stay on the space station and join the Expedition 16 crew, and Leo Earhart's will return in his seat. Let's see, we can't tell who we have here with that visor down. I can't read it. Ah, there we go. Bob Bankin, first-time flyer. So he's ready to go to Air Force officer, Air Force major. Got Jerry Ross there, veteran astronaut in the blue suit. He's leads up our VIT team, which does a great job getting us ready. Here's Takao Doi from the Japanese Space Agency. His second flight, he flew on an earlier shuttle flight back in the 90s, late 90s. Of course, it's significant for him in that they're taking up the first elements of the Japanese portion of the space station. Rick Linehan here, it's his fourth flight. His last flight was to Hubble, so this is his introduction to space station, and he's the lead spacewalker on the crew. And finally, we got Mike Foreman here, Navy captain, test pilot. This is his first flight as well, and he's one of the spacewalkers. And I know I just talked to him a little while ago, and he's really looking forward to this. Waited a long time. And let's go ahead and watch the crew come out here now.
And they're on what floor are the astronaut quarters on there? The third floor. Mm-hmm.
Yeah, they're on the third floor. Coming out of the suit room, and just off to the right there goes down to the dining room and some of the other facilities, computer room. So they're getting on the elevator here on the third floor, and they're going to go down to the first floor. Come out of the elevator, take a 90-degree right-hand turn, and then go out the exit of the building, and that's where we'll pick them up on the walkout.
They called you up. Okay.
So some of the team there that we see getting on the Astrovan there, who's going out with them?
Well, the chief of the astronaut office is among those going out, Steve Lindsay, as well as the director of flight crew operations, Brent Jett, and then a couple of other support engineers.
This is shuttle launch control at T-minus 2 hours, 48 minutes, 6 seconds, and counting. Here in firing room 4 of the Launch Control Center, we're joined now by Scott Higginbotham, who is the payload manager for STS-123. And Scott, we're going to, knowing that you've spent a great deal of time with these payloads that have been with us here over the last, golly, how long has it been since these arrived?
Well, we've been processing the hardware for a little over a year, but the planning for this mission has been in the works for well over a decade.
Well, we're going to look at some tape right now, and you can tell us some of what we've done to get the Kibo logistics module and the Dexter ready to fly.
Very good. The Japanese experiment logistics module pressurized section arrived via ship from Japan on the 12th of March of last year, and here it's being lifted from the ship and placed on a flatbed truck. That took place on the 13th of March, and then it was taken overland to the space station processing facility. The trip from Japan by ship took over 30 days and came across the entire Pacific and through the Panama Canal to Florida. The hardware spent about 7.5 months being processed in our facility, and here is a view of the flight crew that came down numerous times during the flow, but in this particular case in mid-October to do their final evaluation of the flight hardware. The hatch of the PS was closed for flight on the 15th of November after the 8 racks were installed. There are 5 systems racks, 2 payload racks, and 1 stowage rack inside the PS. The PS was lifted on the 27th of November and moved down to another work stand where we could weigh the element and perform our final joint NASA and JAXA activities, getting the hardware ready to fly. And here you can see it flying over its big sister, the PM module, which will fly next with us on the 1J flight, STS-124. The PS module fully outfitted weighs about 19,000 pounds. On orbit, it will be pre-positioning racks for use in the PM module. The SPDM, or Dexter, arrived from Canada on the 19th of June of last year, spent a few months processing offline, and then on September 25th, we started the hoist of the 3 major components of SPDM onto the Space Lab pallet. SPDM will be a robot on orbit attached to the station robotic arm to replace spare parts on the outside of the station. And like with the PS, the crew came down and performed some very close evaluation of SPDM, particularly because during this mission they will be assembling it on orbit. And this is a view of the installation of one of our many sidewall payloads flying with us on this mission. This is the MISSI 6 experiment. It has 2 sample exposure cases called PECs, or passive experiment containers, and they are being installed under the sidewall of Endeavour's payload bay. On this mission we have 7 different items, 3 U.S. spare parts and 4 payload components mounted on the sidewall of Endeavour. I think that's the most we've ever flown on any given mission. Finally, after all the work was done, the PS module was lifted for installation into our transportation canister on the 8th of February of this year. This was in anticipation of delivery out to the launch pad. For my parents back in Missouri, the guy in the red shirt there at the bottom, that's me. And here is the element being rotated before it's installed into the canister. You'll notice there are some shields missing from the side of the module. They were installed after the element was put down into the canister. Next, we're going to see the lift of the Space Lab pallet and SPDM atop it. This occurred on the 11th of February of this year. Sadly, for me at least, this is the last planned flight of a Space Lab pallet. This hardware dates back to the 80s when we flew a number of Space Lab missions. It was built by the Europeans for our use. After both elements were in the canister was rotated to vertical, and here you see on the 15th of February the canister departing for Pad A. We have a specialized facility here at KSC where we can rotate these canisters from horizontal to vertical and back the other way. The trip to the pad takes about 3 hours. We go very slowly to avoid inducing any vibrations into the spacecraft. Some beautiful footage here of our rollout right at sunset. And here the canister is finally arriving at the launch pad. The canister is hoisted up into the rotating service structure. The doors of the canister are then opened, and the payload is extracted using a 5-story tall gantry called the payload ground handling mechanism. It picks both of the elements up out of the canister and pulls them back into the rotating service structure. The canister doors are then closed, it's lowered, and it is transported away. Once the shuttle arrives at the pad, the rotating service structure comes back around, and that payload ground handling mechanism installs the payloads into the orbiter, which is what you see here. Here's the last view of the PS and the last view of SPDM taken on the 18th of February. And finally, on the 19th of February, the payload bay doors of Endeavour were closed for flight, marking the conclusion of our ground processing campaign for both elements.
There's probably a fairly simple answer to this, but why didn't we launch everything with Kibo together?
Well, Kibo is a very large assembly of hardware, too large, in fact, to fly on any one given shuttle mission. So the hardware is being distributed over 3 different flights. We have this mission that we're going to launch here in the morning. We have the 1J mission that will fly in late May. And then we have the 2JA mission, which will be flying next spring. And those 3 flights will be carrying up the 5 major components that make up Kibo. The first launching on this mission, the PS. On the second mission, we have the large pressurized module, the largest pressurized module of the ISS. And on the front of it is their robotic manipulator system, or RMS. And then on the final flight, we have 2 exposed facilities, one the exposed facility, and the second the experiment logistics module exposed section. And together, they all make up Kibo, which means hope in Japanese.
Scott, we saw the Kibo pressurized module laboratory there in the background. What are some of the things going on now and between now and May when it's launched?
Well, we actually have finished our processing on the PM. It is done and in dwell and waiting for its ride to the pad,
it's ready to go.
Which right now it looks like we'll be installing into the canister somewhere around the 21st of April, going to the pad the following week, getting into the orbiter around the 1st of May, doing our final closeouts, and perhaps closing the doors for flight around May 6th, all in anticipation of a launch on May 25th.
Well, Scott, thanks very much for coming up and talking with us about the payloads for our Japanese, and Canadian partners. And we'll look forward to talking to you again when the Kibo Laboratory is launched in May. Thanks very much.
Thank you, George.
Thank you. In just a moment, we'll be joining the STS-123 astronauts as they arrive at the launch pad. At T-minus 2 hours, 39 minutes, 6 seconds, and counting, this is Shuttle Launch Control. The Astrovan is now approaching the surface of Launch Pad 39A, and in just a moment we will see the astronauts disembark and prepare for their ride up the fixed service structure to the orbiter access arm. In the background, we see the hydrogen flare stacks burning off the residual impurities, just as much as an oil refinery does that in the refining process. Here with us now at the Public Affairs Console in Firing Room 4 is Ken Tenbush. He is Endeavour's flow director, and he has been working very closely with the launch team on Endeavour since it returned from its last flight, getting it ready for launch on STS-123. And Ken, welcome. We're glad to have you here for the first time and ready to talk us through some of what you had to do on this flight to get Endeavour ready to go today. So if we can go ahead and roll the tape, we'll let Ken begin to tell us what's going on.
Sounds good, George. Very good to be here. And as you can see right there, you've got the ET arriving from Louisiana. It basically is taken from Louisiana to Cape Canaveral via the Freedom Star, which is one of our booster recovery ships, and then a tug takes it up the canal, up to the dock you see there, and then the external tank is rolled off of the barge, and then takes a short half-mile trip over the VAB. And as far as with the VAB itself, since I got a few minutes here, it's quite a building, 525 feet tall, floor space of about 8 acres, and you can see the external tank there and the 3 parts of that external tank. The pointy piece there is the LOX tank. The lower part is the LH2 tank, and there you can see the composite nose cap of the external tank. And then in between those 2 tanks is the inner tank, and you can see that that's considered like the structural component of the external tank. Some people call that part of the external tank the backbone, and you can see there now that it's in the cell with the umbilicals that feed the LH2 and the LOX into the main engines, into the main propulsion system. You can see Scotty sitting there, Scotty Dorton, one of our more experienced technicians, watching the external tank being lifted out of the cell. The tank itself is quite remarkable in its own right. It's 154 feet tall, 27.5 foot diameter, holds 500,000 gallons of propellant for the main engines. Empty, it's only 58,000 pounds because it's just a aluminum lithium structure, very thin. But once it's loaded up, it weighs over 1.5 million pounds. So again, quite a remarkable piece there. You can see as it's being lifted out of the cell, eventually taken across over to the integration cell on the other side of the vehicle assembly building, where it's taken in between those 2 solid rocket boosters. There's attach points up at the forward end and also at the lower part as well, and you can see the umbilicals now coming into view where one of the attach points is to the orbiter. And you can see technicians closely monitoring the tank as it's coming in between the boosters. There's a lot of very tight clearances on the external tank as they're lowering it into position. You can see the LOX feed line going up there on the right-hand side. Technicians again looking at it. The foam itself, the tank is covered with foam, about 1 inch of foam in most of the areas to keep any ice forming there. And while they're doing all the processing over in the VAB, they're also processing over the orbiter processing facility. And you can see there the main engines being installed. The main engines have to be removed and refurbished every flow. And then you can see them here going into the aft compartment and working some of the installation there on the orbiter. Quick view there of the payload bay area. And then after a good 3.5, 4 months of processing, the orbiter was being rolled out of the orbiter processing facility. You can see the orbiter rolling over. It's you can see on the underside of the orbiter there's on the order of 25,000 tile on the underside of the orbiter. Quite a bit of work was done over in the orbiter processing facility. They had a lot of good modifications made as far as putting in some a harder tile up and around some of the critical areas on the underside of the orbiter, at the nose landing gear and the main landing gear areas. And you can see now that the orbiter is actually being lifted off the transporter. There's 2 cranes that do that. There's a 325-ton crane and a 175-ton crane. They lift it up, as you can see, the transporter rolled out of the way, and then the vehicle is rotated to a vertical position. One of the cranes is disconnected, and then you have the 325-ton crane actually going up and then starting to lift that in to the integration cell so that they can mate that to the external tank. The orbiter itself is 122 feet tall, 78-foot wingspan, and you can see there they actually have to rotate the orbiter somewhat to be able to get it over that transom. The weight of the orbiter is 200,000 pounds. Probably a good point here to mention the fact that STS-123 is the 122nd flight of the shuttle, Endeavour's 21st into space, and the 25th flight to the space station.
You can see it there in the integration cell being mounted. There's a forward location where they mount the bipod struts, and then the aft area as well. Now, after 7 days of checkout in the VAB, making sure everything works fine, then the crawler transporter comes up underneath the mobile launcher platform, and then they lift it up and then start to make the slow trip over to pad A. Kind of interesting about the transporter is that it up on the surface there, it's 131 feet long, 114 feet wide. It can about the size of a regulation baseball field. And the crawler transporter itself weighs 6 million pounds. It gets 150 gallons of diesel fuel per mile. So it's not the best gas mileage in the world, but it does get the job done. And the trip itself, it's only 4 miles, but it takes about 7.5 hours to actually get to the pad surface. They go about 0.8 miles an hour, and 22 days of checkout and a lot of work done at the pad, and then they're ready to launch. As you know now, we're about 3 or 4 hours away from a launch tonight, hopefully. And again, the team has done just a fantastic job as far as putting that vehicle together and getting it ready for launch tonight.
Ken, how long is it once Endeavour gets back before it launches again?
Our next launch right now is scheduled for mid to late October. So it's got quite a long time before it launches again, but looking very excited about working through that processing flow as well and launching again in that time frame.
Well, Ken, thanks very much for coming by and telling us what we've done to get ready for this flight tonight. And we'll look forward to seeing you back again on Endeavour's next flight.
Very good, George.
Thank you.
Enjoyed it. All right, take care, sir.
And attention on the net. This is the NTD conducting the launch status check. All stations verify ready to resume count and go for launch. OTC? OTC is go. TBC? TBC is go. PTC? PTC is go. LPS? LPS is go. Houston flight? Houston flight is go. MILA? MILA's go. STM? STM is go. Safety console? Safety is go. SPE? SP is go. LRD? LRD is go. SRO? SRO is go. You have a range clear to launch. And CDR? CDR is go. Launch director entity? Launch director. The launch team is ready to proceed. Okay, I copy, Steve. Thank you. Chief Processing Engineer, verify no constraints to launch. No constraints, Mike. We're ready. Okay, Charlie, thanks. KC Safety and Mission Assurance. KC Safety and Mission Assurance is ready to go, Mike. Thank you. Payload Launch Manager. Okay, Mike, on behalf of our international partners from the Japanese and Canadian Space Agency, your ISS team is ready to proceed. Okay, thanks, Gennaro. Range weather. Weather has no constraints for launch. Thank you, Todd. And Ops Manager. The Launch Director, Ops Manager, Mike, the MMT is not working. Any issues? You are go for launch. Thank you, sir. Endeavour Launch Director. Go ahead, Mike. Okay, Dom, vehicle's in great shape. The weather is go. In fact, it should be an interesting flight for you to punch through the clouds tonight. So on behalf of the KSC launch team, I'd like to wish you good luck, Godspeed, and we'll see you back here in 16 days. Well, Mike, you just made people smile around the world, and you've got 7 smiling faces on board here. We'd like to give a special thanks to our families, KSC's Endeavour whole crew, our friends in Houston and Canada and for JAXA. We'd like to say konnichiwa, domo arigato, and banzai. God truly has blessed us with a beautiful night here, Mike, to launch, so let's light him up and give him a show. That sounds great, Tom. Thank you very much. Good luck to you all. And NTD, with that, you are clear to launch Endeavour. Copy, clear to launch. Thank you.
The countdown clock will resume on my mark. 3, 2, 1, mark.
T-minus 9 minutes and counting.
GLS auto sequence has been initiated. GLS is go for orbiter access arm rechecked.
Endeavour OTC, we celebrate your international mission as you expand the station into our first global village in space. Okay, Endeavour copies.
GLS is go for orbiter APU start.
PLT OTC, perform APU start.
OTC, PLT, that's in work.
CDR OTC, reconfigure heaters.
CDR, Wilco.
And in less than 10 seconds, we'll be configuring the main engines. We'll be putting the engine through a steering check before we put them in start position. See them now going through a gimbal check or a steering check, steering test.
PLT OTC, clear, caution, warning memory, verify no unexpected errors. OTC, PLT, that's in work.
About to retract the gaseous oxygen vent arm or the beanie cap.
OTC, PLT, caution and warning memory is clear with no unexpected errors. Copy, and Endeavour, close and lock your visors and initiate O2 flow. Endeavour copies visors and O2 flow. Thanks.
GLS is go for EP, LH2, pressurization.
T-minus 1 minute and counting. Final steering check of the solid rocket booster commands is being performed. Turning off the SRB joint heaters. Closing the liquid oxygen and LH2 fill and drain valves. Coming up on the handoff to Endeavour. T-minus 31 seconds. The handoff has occurred.
Auto sequence start.
25. 20.
SRB nozzle gimbal check. Arming the firing chain now. Sound suppression water system is armed. Rain safety systems armed. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of Endeavour, going where east and west do meet at the International Space Station.
Houston now controlling.
Houston, Endeavour, roll program.
Roger, roll, Endeavour. The roll maneuver is complete. Endeavour is in a heads-down position on course for a 51.6 degree, 136 by 36 statute mile orbit. The Florida coast gets an early sunrise as Endeavour heads out on a course to intercept the International Space Station in a day and a half.
Endeavour, your go at throttle up. There's no action on the left RCS messages. We'll have words later.
No, go at throttle up. Copy, no action on the RCS message match.
Endeavour's heading out 51,000 feet in altitude, 10 miles from the Kennedy Space Center, downrange 11 miles. Three hydraulic systems in good shape, as are the electricity-producing fuel cells. Three good main engines at 104% of rated thrust. Coming up on staging, the burnout of these twin solid rocket boosters at 2 minutes 5 seconds. SRB separation confirmed.
Endeavour, press to MECO and single engine Zaragoza 104.
Endeavour, press to MECO, single engine Zaragoza 104.
Endeavour can reach a safe orbit on 2 engines now as the vehicle is rolling to a heads-up position for good communications through the tracking and data relay satellite system.
Endeavour, your shutdown plan is nominal. You are go for the plus X, no go for the pitch.
And go for the plus X.
Six minutes, 45 seconds into the flight. Endeavour is 486 miles from the Kennedy Space Center at an altitude of 65 miles.
Endeavour, single engine press 104.
Endeavour, single engine press 104.
And Endeavour can reach orbit on 1 engine should 2 fail at this point, but all 3 are still performing well.
Okay, Jim, thanks.
Flash evaporator system operating in its backup or standby or secondary system. All cooling on board in good shape. Hydraulic systems, fuel cells also in good shape. 7 minutes, 30 seconds into the flight. Standing by for throttling to maintain the 3 times gravity on the vehicle and the crew on board. Endeavour is traveling 16,000 miles per hour, downrange 780 miles, altitude 64 miles. Standing by for main engine cutoff confirmation. Main engine cutoff confirmed. Standing by for separation from the external tank. Endeavour flying away from the external tank.
You like that switch? Yeah, good switch. ATC, PLT, caution and warning memory is clear with no unexpected errors. Copy, and Endeavour, close and lock your visors and initiate O2 flow. Endeavour copies visors and O2 flow, thanks.
TLS is go for E2, LH2, pressurization.
Oh, look at the bonnet. That's pretty cool. Really cool.
That bonnet thing's retracting. We can see it passing in front of the window.
Yeah, I can see it too from here. Okay, on ICOM, CDR, DLT, MS1, MS2, MS3, MS4. Madre! 1 minute, 30 seconds. All right, guys. Here we go. You guys are the best, man.
All right, I love you guys. You guys are the best.
You guys are the best.
You guys are the best.
I am. You guys are the best.
A little bit of a bias to the PC booster right there, just so you know.
Okay.
It ain't 11 PC right now. It's 14.
1 minute.
seconds. STS is go for auto sequence start.
25. 20. 15. 10.
STS is go for maiden start.
Water flow, that's pretty cool. Start. 3 to 100. 102, 102. Auto. Here, 1 1000, 2 1000, 3 1000. Rolling. Houston Endeavour, roll program. LVLH left. LVLH right. Roger, roll, Endeavour. Jet. Roger. Digital. Mark 86, throttling. 3 at 71. You can look at the engine display if you want, Knox. Roger, thanks. Mark 1.17, throttling. 104. Okay, I'm going to check that fault zone.
Endeavour, you're good with throttle up. There's no action on the left RTS messages. We'll have words later.
Go with throttle up. Copy, no action on the RCS message match. Looking good, guys. 90 seconds. 30 seconds, 39 degrees. DC, less than 50. DC's. 103, 103. That was bright. That's cool. Mikos are looking good to me. Hey, they look like they've converged. The ohms assist has started. You can close your pseudo-2 and open your visor. All right, thanks, Bob. Oh. Smooth ride. That is smooth. Okay, the Mikos are reconverged. Good. Me too. Zaragoza. Alrighty. Okay. Endeavour, 2 engine Zaragoza. 2 engine Zaragoza. That T looks good. Good job, Mike. I see some stars up ahead. Woo! Okay, the ohms assist is almost complete. Okay. Are you looking out the back? Up with your mirror there. Like fire back there. It'll be negative return. Okay. Heads up roll next. Endeavour, negative return. Endeavour, negative return. Endeavour for Dom, the FES is shut down. We'll take step 1 of the VAP out T-high. VAP out T-high, step 1. Ohms assist is complete. VAP out T-high, A off, B on. Ready? I'm ready. A off, B be on. 30-second timer, Mike.
It's running.
Houston, step 1's complete. We copy down, we're looking.
Temps coming down.
Endeavour, press to ATO. Endeavour copies, press to ATO.
Temp looks good.
Okay, thanks, Mike. Just keep an eye on the mid-deck, we're at Mach 12. Getting ready to roll.
Engine ops 3.
Roger. Endeavour, single engine ops 3. Endeavour, single engine ops 3.
Hey, we're rolling.
Rolling left.
That's to Miko.
Okay.
Single engine Zaragoza.
Endeavour, press to Miko and single engine Zaragoza 104. Endeavour, press to Miko, single engine Zaragoza 104. I don't know if you can see anything out that window boxing that roll, but...
No, I can't. It's all dark, but I can see the stars in front of us.
Endeavour, your shutdown plan is nominal. You're go for the plus X, no go for the pitch.
Hey, you want me to set?
Nominal shutdown and go for the plus X.
Ow.
Good enough, cheese.
Boom. Sorry to look my arm. Single engine, press to Miko.
Okay. Endeavour, single engine press 104. Endeavour, single engine press 104.
Okay, coming up on 3 Gs.
Endeavour, the fence is looking good on Pri B. Okay, Jim, thanks. Looking for 2581.
Roger. That's that strobe that they were talking about. Okay, we're throttling back.
More seconds on the mid-deck, guys. Copy that.
Whoa, baby. Like 2581.
2581.
Holy moly.
Okay.
Hey, dudes.
Okay.
Yeah. Set flashing. I guess that was the negative 104.
Got HA plus, so we're going to go 11 seconds. You ready?
Ready.
On the 5, going to 16. Okay. Failures we had was the FES and the jet. I don't see any problem with taking our Ohms engines off. I agree.
Now, Ohms engine is coming off. Ready?
Ready.
Left.
Endeavour, nominal MECO, Ohms 1 is not required.
Endeavour copies. Ohms 1 not required.
And Dom, we have no follow-ups for you at this time for VAP out T high or left RCS jets.
Endeavour copies. Thanks, Jim.
Okay, so
Post Ohms 1.
the manifold 2 leak on the RCS, just for your info. Okay.
That again, Box?
It's manifold 2 on the left RCS. We have the leaks there. You see those?
Yeah.
It deselected 3 of the 4. I'm a little bit confused about the signature, but we...
No action, so...
Right, I got you. I'm just thinking.
We're waiting for MPS dump complete. So on this page, Mike, I went to ADI to ref, but we're skipping down to MPS dump complete.
Get your ADI box.
Roger that, box down.
By ADI?
To ref.
Okay, to ref? Yes, I'm sorry. That's just for Dom.
Okay, that's all right.
That's really loud. Is that normal?
A lot of jet firings.
Yeah, there are. There's that ohms. The ohms is lying to us. This one really should be 70, I think. Isn't that the one that they were talking about that was a bad quantity?
Yeah, I think so.
Yeah. So we're going to just take this to RCS. There you go. Got lots of RCS.
We're waiting for the body flap light to go out.
Roger.
About a minute.
Roger. That's pretty cool. Look at that. Floating.
That was an easy sim for you, Box.
Yeah, but it was a little bit more like the sim than I expected.
Yeah. If waiting for the light to go out, and then...
Okay, the light's out.
On the next page... MPS dump complete, hide MPS TVC ISOs.
Okay, 3 switches.
5 seconds each.
Okay. Coming closed.
Endeavour, Houston for the white pages.
Go ahead, Jim.
Dom, you have a go for APU height shutdown when you get there. On page 3-4, tail-only control is not required. Under FES and heater activation, you can delete the L1 step. We'll take AC bus sensors as written, and we'll be ready for 105 on time.
Jim, we copy all. On the FES and heater, we're going to delete the L1 step.
Okay, I've got that complete.
That's a good read that down.
Okay, flight controller powers?
Okay, coming off on the right.
Left. Apps auto. Apps auto. Side shutdown.
Okay, Bob. Hey, check if you auto shutdown 3 seconds. I want to get my seat back here. Isn't like the sim. There we go. Mo better. Okay. Ready? Boiler control powers? Correct. First check the AP auto shutdown 3 are enabled. Yeah, they're enabled. Boiler power 3 to off. 3 boiler powers come off. Boiler N2 supply 3 to off. 3 N2 supplies coming off. APU operate switch, 5-second interval. Okay. 3 to off. Okay, here comes number 1. Roger. Okay, that's expected. Okay, that's expected. Okay. If you fuel tank valve, 3 to close. Okay, stand by 1. Okay, everybody's looking pretty normal. Okay, on the tank valves, good switches. Off for 200. Okay, I agree. APU controller power 3 to off. Okay, controller powers are coming off. And Mike, I'm going to go to fence and heater rack here. Feed line heater 201. Feed line heater. Let it go, Rick. Which is coming to 1. Okay, that show us complete. Yes, and no, I'm there, so that's, I agree. All right. O2 and H2 switches for you, Box. Okay. O2 tank 1, 2 heaters, Bravo, 2 to auto. Okay, here come the O2s, Bravos, they're coming to auto. And H2 tank 1, tank 2 heaters, Bravo, 2 switches to auto. Okay, that's done. I'm going to start on Endeavour Houston. In 1 minute, we will be unable to speak to you for 1 minute due to spreading. Endeavour copies. 812, Bob. Yeah, I'm going to start on step. And Dom, just a quick tag up on EMS2. Your tag right now is 38:30. We expect to burn the onboard targets. And for pages 3-6 and 3-7, we have no deltas. Jim, we copy 38:30 and no deltas on 3-6 or 7. That's a good readback. Okay, where you at, Box? Okay, I think we're waiting on AC bus sensors after the APU steps. Okay, and Bob, you getting the APUs? The A12 steps, yep, I'm working on it. Wow, what is it? There's things flying by. Check it out, Dom. Here comes the sunrise. Know when you're ready for me to read. Go ahead, Mike. All right, APU, heater tank, fuel line, water system 1A, 2A, and 3A, 3 auto. APU, heater tank, fuel line, H2O assist, 1A, 2A, 3A. That's complete. Okay, Box. Work, AC bus sensors. 3 off, 1 second. Then auto trip. Okay. When the gold clips came unstowed. Houston Endeavour, here comes Ops 105.
Und wir haben den Start vorhin verfolgt mit der Hilfe von Professor Ulrich. Walter ist wieder bei uns. Herr Walter, was wir da gesehen haben, war das, was man einen Bilderbuchstart nennen dürfte?
Perfekt. Es hat alles sauber funktioniert. Besser könnte man sich das gar nicht vorstellen.
Was sollen die Jungs denn da oben machen?
Die sollen verschiedene Außeneinsätze machen und sie sollen einen Teil des japanischen Labors, das tatsächlich aus 2 Teilen besteht, das zweite Teil wird nächsten Monat starten. Also der erste Teil soll aus der Ladebucht des Shuttles herausgeholt werden und es wird temporär an einen Zwischenport angedockt und erst wenn das große Modul im nächsten Monat kommt, dann wird es wieder umgesetzt und an dieses große Modul angesetzt werden.
Was wir gerade noch mal sehen, ist, wie die Klappe über dem ganzen, über der Fähre hochgeht.
Beanie Cap, dort wird der Wasserstoff eingeleitet in diese großen externen Tanks. Hier sieht man, wie die Funken auf die Rampe sprühen. Hier werden gerade die Flüssigkeitsantriebe gezündet, funktionieren wunderbar. Und dann werden auch gleich die Feststoffraketen gezündet, das sehen Sie hier. Und dann geht's ab. Am Anfang ziemlich langsam und dann immer schneller, weil eben relativ viel Treibstoff daraus geblasen wird.
Gibt es schon erste Rückmeldungen von der NASA bezüglich dieser Schaumstoffproblematik?
Ich habe gerade nachgeschaut, nein, noch gibt es nichts. Tatsächlich werden Sie jetzt mit einer Kamera das ganze Shuttle sich abtasten und schauen, sind wirklich Schaumstoffteile abgegangen und sind auch Teile des Shuttles davon verletzt worden.
Können Sie beschreiben, wo sie ungefähr gerade ist, die Endeavour, und was da jetzt an Bord passiert?
Also sie fliegen mit 28.000 Kilometer pro Stunde, das ist etwa 10 bis 15 Mal so schnell wie eine Gewehrkugel, zusammen um die Erde. Voraus fliegt die internationale Raumstation, dahinter der Shuttle. Die fliegen also so um die Erde und in diesen nächsten 2 Tagen wird versuchen, das Shuttle langsam an die internationale Raumstation heranzukommen, dann anzudocken. In dieser Zeit wird eben das Shuttle untersucht, es wird geschaut, sind Verletzungen da, sind irgendwelche Kacheln verletzt und wenn nicht, dann kann man einfach so weitermachen. So wird es wahrscheinlich auch sein.
Da ist ganz schön Gedränge an der ISS, denn viele Frachten und andere Ladungen kommen ja auch noch an. Sozusagen.
Ja, das ist richtig. Unterwegs ist das ATV, das ist ein europäisches Versorgungsmodul. Dort ist viel Treibstoff drin, 5 oder 6 Tonnen Treibstoff sind da drin, insgesamt 8 Tonnen, aber auch Lebensmittel. Alles, was ein Astronaut da oben so braucht, ist da drin. Das dockt automatisch an, nachdem der Shuttle in etwa 14 Tagen abgedockt hat.
Und gerade so in diesen Minuten, was machen die? Machen die so ihre Sicherheitsgurte langsam auf?
Das ist sehr
so,
interessant. Nein, sie ziehen erstmal diesen Raumanzug aus, wo Sie gerade sagten, der sieht so orange aus. Ich kann Ihnen sagen, der Duft im Shuttle ist dann nicht ganz so toll, weil wenn 7 Astronauten ihre Anzüge ausziehen und dann da gelegen haben, der Duft ist nicht ganz so toll, dann ziehen sich ganz normale Sachen an. Sie sehen das hier, da kommen die Astronauten raus, das sind diese orangenen Druckanzüge. Übrigens, da geht kein Lüftchen rein und raus, das ist wie in der Sauna da drin, das ist also äußerst ungemütlich und das ist eben der Grund, warum man sie alle auszieht, dass der Duft dann im Shuttle nicht so ganz toll ist und dann zieht man sich die ganz normalen Sachen an und dann geht es eigentlich erst richtig los.
Was trägt denn der Astronaut unter diesem Anzug?
Das ist sehr interessant. Es ist eine Art Leinenunterwäsche, die sehr gut sitzt und ziemlich viel Schweiß aufsaugen kann. Das ist eben in so einer Sauna sehr wichtig.
Aber jetzt kann man sagen, die riskanteste Phase ist vorbei und es läuft alles nach Plan.
Genau. Also jetzt ist wirklich keine Gefahr mehr da. Ich gehe auch davon aus, dass keine großen Teile der Kacheln am Shuttle abgeschlagen sind. Das werden wir allerdings erst in ein paar Stunden sehen, wenn die Kameras das Shuttle wirklich gut untersuchen.
Der Astronaut Professor Ulrich Walter, ganz herzlichen Dank, dass Sie uns das erklärt haben. Dankeschön fürs Hiersein.
Endeavour ist vom Weltraumbahnhof Cape Canaveral aus erfolgreich ins All gestartet. Sie bringt erste Teile eines japanischen Forschungslabors und einen kanadischen Roboter zur internationalen Weltraumstation ISS. Dort soll die Endeavour morgen andocken. Die 7-köpfige Besatzung wird 16 Tage im All bleiben. Im Lauf der Mission sind 5 Außeneinsätze geplant.
Endeavour ins All gestartet. Sie transportiert ein japanisches Weltraumlabor und einen französischen Roboter zur internationalen Raumstation ISS. Die Mission dauert 15 Tage. An Bord der Endeavour sind 7 Astronauten.